Hello. Our project is named Code Learning with Astronomical Ideas. The core project idea is to create a code learning program based on microbits and astronomical topics. Microbit is a pocket programmable device that allows children and young people to learn how to program in a simple, playful, and creative way. Its integrated sensors, which include buttons, compass, accelerometer, temperature, brightness, Bluetooth connection, LED matrix, allow the development of STEAM projects in which children and young people, almost autonomous and in groups, can learn by doing all phases of design, development, programming, and execution. On the other hand, astronomy is a very attractive topic to young students, contributing for their motivation and in promoting interest in science and technology. Exploring the relationship of programming and astronomy gave us an opportunity to teach how science can be challenging and attractive to young people. The target audience was local students and abroad teachers that can implement this same project in their respective countries. The implementation plan began by creating partnerships with schools that do not have access to this type of technological education due to lack of means, which will permit a selection of children and young people in order to reduce inequalities. The chosen schools were Portuguese School of Mozambique and Portuguese School of East Timor, two Portuguese-speaking countries. Based on the feedback of those teachers, it was created a learning roadmap as a guide to teach coding based on astronomical ideas. The replication of the project was made possible through online training of teachers on those schools. Afterwards, those teachers implement this learning guide with students of their own schools. The resulting guide and training sections aimed at the following. A mission to Mars was decomposed in several phases in order to be replicated in a simplified way through microbit coding and its sensors. Project-based learning included the following projects. Phase 1, astronaut training, reflexes training, and reaction time. Phase 2, rocket launch, acceleration, and measurement. Phase 3, space trip, cabinet pressure, monitoring temperature and radiation, and sound warnings. Phase 4, landing, distance to ground, and contacts. And Phase 5, robot in Mars, robot control, temperature in Mars, and a climate station. For several months last year, all the frontiers were closed in East Timor, so the materials we sent there got stuck in Australia and delayed for several months its arrival. Eventually, all materials got there. Other challenge was the lockdown in East Timor and Mozambique in some periods, during which all presential activities with children were not possible. Teachers, therefore, are delaying at the beginning of the project activities with students that will resume till the end of the year. We can synthesize the project results as follows. 7 online training sessions, which included 12 professors of different disciplines. 10 presential sessions in our science center in Braga, Portugal, in order to develop and test our methodology and create a learning roadmap. These sessions involve 150 students. Sending electronic devices and materials necessary for this project to East Timor and Mozambique. Elaboration of a guide for code learning with astronomical ideas, which is available online. We had also one dissemination activity, both presential and online, at our local university for a public of 20 international teachers from Greece, Estonia, Kenya, Malta, and Portugal. There is still some remaining activities, which is the project implementation by Timor and Mozambique teachers in their own schools. This is planned until the end of the year.